so we have more time for the lab. Let's talk about mission components. So these are the various mission components that you saw in the textbook, but how exactly do these affect the bus? So I created this flow diagram of the different mission components and how they flow down to affecting the spacecraft bus. The top components are defined rather rigidly, so there's not too much design flexibility to change, like the launch provider, for example. So I'll walk through it. Last thing is the components on the bottom are more flexible to change as they are downstream, so that's why you'll see the double-ended arrows. So the subject defines the payload, and the payload really defines the spacecraft bus, and so does the subject. So that's why this thickness of arrow is here. These effects come in play from the payload requirements. The subject requirements flow over to the type of orbit and the type of space environment that we'll see. And that flows down to the spacecraft bus in the way of environment requirements, like radiation, for example. The orbit then defines the kind of launch provider or vehicle that we will pursue. And the launch provider and vehicle then defines the kind of interface and environment requirements that we'll see on the spacecraft bus. Then these kind of go together where you're simultaneously designing a ground station or a spacecraft bus, depending on how defined either of these are in the design stage. So between the ground station and the spacecraft bus, you need to negotiate a frequency that you'll have to license with the FCC. There's also an underlying command, control, and communications architecture that links the ground station and mission operations together. The mission operation relates to the ground station in that the telemetry and command has to be in a certain communication format or architecture, so there are requirements there. And then mission operations can affect the way that we design the spacecraft bus, and the same with the spacecraft bus potentially affecting the way that we conduct mission operations, if there are little quirks to the way that the spacecraft bus functions. Here are general specifications from the CubeSat design specification, which is an externally defined specification document. So really quickly, all parts of a CubeSat must remain attached to the CubeSat during launch, ejection, and operation. We don't have pyrotechnics or propulsion, so I'll skip those. But we also have to follow the FAA's requirements for batteries, which we do have already defined in the kit. We also have to look out for hazardous materials, and we have to look out for materials that have low outgassing. We also are required to maintain a magnetic field below 0.5 Gauss. So we have done that in the kit, but you should be aware of this if you have any payload that that may apply for these requirements. Okay, so really quickly, questions. Are we really able to get a license for the class? And I want to say, hold your horses. Don't get excited about that just yet, because I think we need to apply to the CSLI and have a compelling path forward, because getting a license is very difficult. There's a lot of paperwork involved, so you don't really want to go down that path until you have commitment. And then when it comes to signal paths being uninterrupted, does this happen often on high profile missions? And I'd say it depends on the orbit, but given how high profile missions have unique orbits, particularly for interplanetary or interstellar missions, given that these high profile missions have high priority for ground station transmission and reception, and also given that the deep space network has global coverage, signal paths are often uninterrupted. And that's by design, because we want to have the most mission success for those high profile missions. And then radio frequencies, are definitely getting more congested over time, so it's harder to license a frequency. And the intuition for that is that the regulating agency is noticing that there are more satellites transmitting. And so, with more satellites and more frequencies in the air, all the other frequencies will blend together and look more like noise. So, they want to make sure that we still get something useful of the satellites that are already transmitting. So, there's that limitation or throttling of those that can enter.